Okay, let's have a look at what we did last time and what we're doing today. So do you guys remember Tuesday doing reflections? We traced on the tracing paper, we traced that line, and then we flipped the paper over to do a reflection. We'll be practicing that a bit today as part of our work. Our learning target for today, which is 9.4, is here. Before you leave here today, I want you to know what a rigid transformation is. Okay, I want you to be able to define there are two special things about a rigid transformation. I want you to be able to tell me what that is by the end of our class today. I would also like you to be able to name the three types of rigid transformations, which are written right here: translations, reflections, and rotation. So at the end of the class, I'm going to ask you what's special about a rigid transformation. You're going to tell me those two things, which I haven't taught you yet. And then I'm going to ask you, can you name me the three rigid transformations? And I hope that you'll be able to say translate, reflect, and rotate. The other key piece of today is this notation for corresponding parts, which we call prime notation. I want you to understand what that means and why we do it. Okay, so this is how we label pictures in geometry that involve transformation. So those are our key things I want you guys to look out throughout the lesson today. As we get to them, I'll point them out, and we'll come back to this at the end of our lesson. So let's get to business here. Section 1.2.2, rigid transformations, rotations, and translations. All right, we're going to start off with a little bit of practice with some reflections. And before we do that, I'm going to go ahead and read this paragraph to you and point out some of our notation. Folks, if you can't stop, then I'm moving you right now. Stop. Okay. I want you guys to pay attention as we go through here. That last of our learning targets had to do with prime notation, and we're going to see that in this very first sentence. So the question is, what happens when triangle ABC, clearly they're talking about this triangle, is reflected across line N, which is this line, to form, and don't miss this is it right here, triangle A prime, B prime, C prime. So this is prime notation. A little apostrophe there, we say the word prime. So what we're going to do is we're going to take this triangle, we're going to reflect it and create a new triangle. And so that we can tell which point goes with which point, we're going to use the same three letters for A, B, and C. But so that we can tell which one was the original and which one's the new one, we're going to use this prime notation. So that's what prime notation is for. It's so that when you look at a picture and you see something with A, B, and C, and you see another shape with A prime, B prime, C prime, you know which one's the original and which one comes after. And you know which pieces match up with one another. So what I'd like you guys to do right now is go ahead and use your tracing paper to reflect this triangle across this line. Some of you were able to do this without the tracing paper on Tuesday. If that's the case, feel free to go ahead and do it without. We did have some folks out, so I'm going to go over how to do this with the tracing paper. So I'm going to trace the triangle. And then the key thing is you also have to trace the line of reflection. And I like to put a dot on the line of reflection and then also put that on my tracing paper. And when I flip it, that dot needs to stay in the same place. So when I reflect, I flip my paper over, line up the line of reflection, line up the dot, and there's my reflection. And then I just need to transfer this over. And I'm just going to do it one piece at a time here. All right. On your first test, which is going to be in about 4 weeks, there's going to be a whole page where you're going to be doing different transformations. One of them is going to be a reflection. How do you think I did? If you guys play the part of the grader here, did I do that reflection correctly? I did. I would still get a -1. I would. You're right. Absolutely would. I would be losing points. Points on the table here. What did I forget to do? We haven't actually done this yet. We have not labeled it. Okay, and this is so easy to forget to do. Prime notation is not hard to do. It's hard to remember to do. For me, anyways. So this is my new location for A, so that's A prime. And then I'm glad I'm writing in pencil because something doesn't feel right about what I just put on my paper. Can you check that for me and help me out? Is that not right? Okay, so they need to correspond. This was the original location of B, and when I reflected it, it moved to here. So B should be here. B prime should be here. And then C was the one that was on the shorter side here. So C prime would go there. All right. So let's make sure we did this first part. It said reflect triangle ABC across line N to form triangle A prime, B prime, C prime. Okay, so we're up to here right now. And then take triangle A prime, B prime, C prime, and reflect it across line P to form a new triangle, A double prime, B double prime, C double prime. So go ahead and take that new triangle that you just drew, reflect it one more time across this line this time, and that's going to give you a new triangle, and when you label it, it'll still be A, B, and C, but this time you'll have 2 apostrophes after each one. Oh, man. I don't have enough tracing paper to do this. I can maybe pull this off without tracing paper. Yeah, we can just kind of count. Some of you have figured out that you can just count how far it is away from the line and then go on the other side by the same amount. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I pulled it off. I think I did it right. Oh, except for one thing. Don't forget to label them. So on this test you're going to take in 4 weeks, there's going to be a whole page of these, and at the bottom of the page it's going to say in like double-size font, bold, all caps, don't forget to label using prime notation. Double primes, thank you. And someone's still going to forget to do it. We gotta come up with some way to remind ourselves to do it. So easy to forget. It's easy to do, easy to forget. All right. Any questions so far? So far, this is just exactly like what we did on Tuesday. Are you guys still feeling pretty good about reflecting? All right, so here's the big question on this one. Ignore that middle triangle and tell me this. Would there be some way to take my original triangle ABC and do some kind of transformation to it so that I went straight to this final triangle in a single move instead of in 2 separate moves? We just did it with 2 separate reflections. Could we have taken this thing and in one single move gotten it to that location and orientation? I'm seeing some yeses. How would I do it? So let me line it up here. Give me instructions. What am I going to do with my tracing paper to get this triangle to line up onto this one? Just, there we go. Slide it over. I heard rotate a minute ago. Is there a way we could rotate it to get it there? We could get it in the same location, but I think it would end up upside down if we spun it. But I want you to keep rotations in mind because they are going to pop up later on. So how will we get it from here to here? We're just going to slide it. The technical term for that is translate. Transmission, translate, transform. We're going to translate, and when we talk about translating, we have to give some specifics about it. With reflections, we have to tell it what line we're reflecting over. With translate, we have to tell it which direction and how far. So it's definitely to the right by how many units? I counted earlier and got 28, but I'm not super confident. Is that what you guys are? 28? Okay. We'll say by 28 units. So the technical name for this, when we just move something in any direction, if we're just sliding it around, it's a translation. What are some other words for that? Some words that you've heard me say just a minute ago is slide. Shift comes up a lot. In fact, in Algebra 2, when we get into transformations, usually we'll be talking about shifting instead of translating. It's also a shorter word to write. Any others? Slide, shift, skedaddle. I love it. How do you spell that? Ski, it, with a D or a T?
Oh my God, no.
D-D-L-E? Skedaddle. Okay. Skedaddle.
Yeah, skedaddle.
That looks like skidoo.
Who said double T?
No? Sorry. Is that not a thing anymore? All right. We're moving it. That's the main thing. We're moving it. All right. Hey, guys, I want us to take some pretty important notes here. So one of our learning targets was about prime notation. Do you all feel like you've mastered that at this point? When you look at this picture, if I just showed this to you, would you be able to point out which was the original triangle, which one was the second, and which was the third, just based on those apostrophe, those primes? So you got that concept down. All right, one of the other things was about rigid transformations, and I want to tackle that one right now. So in lieu of answering this question, we're going to take some notes down here. So what I need you to know is that a transformation is anything that you can do to change a geometric object. Anything that you do to change something. There are many different types of transformations. I'm going to list the official words for 4 of them here. These are all types of transformations. One of them is the thing that we did on Tuesday when we were flipping the tracing paper. Starts with an R. Reflect. That is a type of transformation. One of them is the thing that we just did. If we just slide or skedaddle something from one place to another. That is no, that's translate. But that other word, and I'm glad you're hanging on to that because that's next. That other R word that we've been hanging on to for a little bit, that's in there too. Yes, spinning, rotating. And then, yes, nailed it. I told you it was going to come up here in a minute. There's a third one that has to do with making things bigger or smaller. It starts with a D. Dilates. So these are all types of transformations, and there's other types of transformations too, where we stretch something horizontally or we stretch something vertically. There's Z transformations that cause all kinds of weird stuff to happen. So there's lots and lots of different transformations. These are just types of them, and these are the most common ones that we'll be dealing with. Now, some transformations are special transformations. Those are the rigid transformations. 3 of these things are rigid transformations and 1 is not. Now, if you think about the word rigid transformations, what does that word make you think of? Doesn't change shape, because if something's rigid, it's not gonna bend or stretch or anything like that. It's gonna be rigid. So yes, the shape stays the same, and what else stays the same? The size stays the same. And those are the 2 key things for rigid transformations. I'm going to write this off to the side. Rigid transformation. Remember, this is one of our key learning targets for today, is for you to know the 2 things that make rigid transformations special. And those 2 things are same and same something and same something. If something is a rigid transformation, it's going to keep the same size and the same shape. Same size and same shape. Of the 4 transformations that we have listed, which 4 of these are rigid transformations? Or which one is not? Dilation is clearly the one that's not. So these 3 here are all rigid transformations. Dilation is not. So one of our key learning targets for today is for you to know what a rigid transformation is, what makes it special, same size, same shape. What are the 3 rigid transformations? Reflection, translation, rotation. Okay? All right, now we get to play with some of these things. So go ahead and flip the page over, and we're going to do some more reflecting. All right, this time we got a diagonal line. Those are the more challenging ones. We like those. So we got EFG this time. Would you please reflect triangle EFG over line V to form triangle E prime, F prime, G prime, and then take that new triangle and reflect it over line W to make E double prime, F double prime, G double prime. Don't forget to label. Use your tracing paper if you need to, especially on that diagonal line. That gets a little bit tricky. Guys, this is going to be the coolest thing that you see all week coming up here in about 3 or 4 minutes. So prepare yourselves. Prepare yourselves for something awesome. Are you guys ready for the magic? This is the coolest thing you're going to see all period. Maybe all day. Potentially all week. Okay, first I got to ask you a question. Same question that we asked a moment ago on the last page. Is there a way that I could do a single transformation starting with this triangle and ending at this triangle? One single transformation. And what I would like you to do, if you think you know the answer, is to trace this thing and then show me by moving or spinning or flipping your sheet how this would move to get to this, would transform to get to this. I told you it was going to become important. Heck yeah. So I'm hearing a lot of people say rotate, but can you make it work? All right.
Oh, I'm there.
Ooh, I like. Okay, I'm seeing something. Have you guys seen rotations with tracing paper before? You just figured it out on your own. That's pretty cool. All right, you ready for the magic?
Yeah.
All right, so trace it on your tracing paper. It's traced. All right. Now, when we do rotations, we have to hold 1 point steady. That's going to be our center of rotation. So take your pencil and put it at the intersection of these 2 dashed lines right here. Put it at the intersection of these 2 dashed lines and hold your paper down with the tip of your pencil. And then start, here it comes, guys, here it comes. Start rotating that paper, but hold that spot in place. Here it goes, it's spinning. Oh, it's good. Is it going to make it? Is it going to make it? Wow! Perfect! Heck yeah. You're right. That point where you hold it is really important, because if I had held it at this point instead and rotated it, it's not going to get there. It's never going to meet up with that other one. Yeah. So you got to be able to have the paper that shows the figure and the point that you're rotating around. But isn't that cool?
I didn't know that.
Yeah, that was pretty cool. All right. Let's describe. Shh. All right, folks, you've been doing a great job. We're getting really close here. Let me get back to where is my packet? There it is. Let's describe this in detail like we did here. Now remember, when we talk about a transformation, we have to give some details about it. So on this one, it is definitely not a translation. That's what this is asking. No. But we're going to describe what did we do. We rotated. And when we rotate, we have to say what point did we rotate about. The center of rotation is the point that we hold down with our pencil or pen tip. And this picture does not have a name for that point. Actually, if you look ahead, it tells it to call this point P. So go ahead and draw P there. So rotate about point P by how much? How many degrees did we had to rotate 90 degrees. And the direction. And the way we do directions is not left or right with rotations. We either do clockwise or counterclockwise. That was in the same direction a clock would go. So I usually do not write out clockwise. I write CW, but I'm going to write in parentheses clockwise. The opposite of clockwise is counterclockwise, and I use CCW for that. So clockwise means we're rotating the same way that the second hand on a clock would rotate. Actually, all the hands on a clock. What I'm going to ask you to do next is to do a rotation on this shape. They're telling you they would like you to rotate it 90 degrees counterclockwise. This time we're going to go counterclockwise. Again, I would abbreviate that CCW. And this time about point Q. So I'll work through this with you because this is the first one we've done with the tracing paper. Go ahead and trace out that L shape. Trace out that L shape and put a dot there where Q is. And sometimes I find it useful when you're doing a rotation to also include an arrow that's pointing straight up. This is going to help us know when to stop rotating, because right now it's pointing straight up. If I rotate it 90 degrees counterclockwise, what direction is this arrow going to end up pointing? It's going to end up pointing to the left. If it was pointing down, how many degrees would that be? That would be 180, because you're doing a half circle at that point, right? And we're going to do some rotations by 180 in our next lesson. So that's cool that you said that. All right, so hold it down at Q and then spin your tracing paper until that arrow is now pointing to the left. That's now 90 degrees. And transfer those points over. Now they didn't label most of the points on this L shape, so we don't really have to worry about prime notation for most of these. Where would Q prime be?
Same spot.
In the same spot. And if that ever happens, if you have a point that doesn't move, then we don't bother with prime notation for that. So it's already labeled once. We don't need to give the same point two different names if it's in the exact same location. So we wouldn't do a Q prime. If you were looking at a picture and you saw a Q and no Q prime, that means that after that motion, it didn't move. All right. How are we feeling? Guys, we're almost done. You're doing awesome. Stick with me here. I'm going to do this last one. We're We're going to do some alternate directions, okay? So ignore what's over here and just stick with me, and this will go a little faster, all right? You guys are going to have a good chunk of time for your assignment. Look at this first group of two squares and focus on the prime notation. Can you tell me which of our three transformations, which of our three rigid transformations would move A, B, C, D to A prime, B prime, C prime, D prime? Would it be a reflection, a rotation, or a translation? Translation. We know that because why? It's kind of in the same orientation, right? It didn't spin or flip or anything. A is still in the upper left. A prime is still in the upper left, just how A was. So this would be a translation. Let's label that. Look at this next set of squares and tell me, what do you think about this? Reflection, rotation, or translation? We think a reflection here. If it's a reflection, there should be some point of reflection. Or sorry, not point, a line of reflection. Can you draw me a dashed line that we would have reflected this thing over? Another way to think about this is if I were to fold it so that these two shapes matched up to each other, where would that fold happen? And that would be right here. And this is, yes, you are correct. This is a reflection. Which means the last one by process of elimination must be a rotation, and it kind of shows a rotation with that little arrow. This is actually a rotation by 180 degrees. And the challenge here is, we know it's a rotation by 180. Can you mark where A prime would end up, where B prime would end up, and where C prime would end up? Now, if you are stuck, one strategy would be to trace your square on some tracing paper, write down where A, B, and C, and D are. Hold your pencil down and rotate it around to match up with the other one. I lost it. Pen works better. My pencil head keeps breaking. And that'll help you see where A and B and C and D will end up. All right. All right. Folks, thank you for your attention today. Before we wrap up today, I got some questions for you. Okay. I'm going to ask you a question, then I'm going to say 1, 2, 3, go, and we're all going to say the answer at the same time. It's going to be kind of chaotic, but that's all right. Okay, are we ready? All right. A rigid transformation has two special things about it. What are two special things about a rigid transformation? Don't say them just yet. Don't say them yet. Don't say them yet. Just think about it. What are the two special things about a rigid transformation? You ready? 1, 2, 3, go.
Same size, same shape.
All right. Same size, same shape. And there are 3 of the 4 transformations we talked about that are rigid transformations. Can you name those 3 transformations that are rigid transformation? Wait. All at the same time. Ready? 1, 2, 3, go.
Translations, reflections, rotations.
All right. Translations, reflections, rotations. And how are we feeling about prime notation? Give me a thumbs up if you're good on that. I think we did great today, guys. Nice job. Thank you, thank you. Somebody want to help me pass out papers? You mind getting that side of the room, and I'll get this side? All right. I am going to give you some hints on a couple of these problems, so if you could just hold off on moving for 1 more minute, it's just going to make your life easy. Trust me. He's got you over here on this side. You're welcome. All right, don't miss this. There's a fine line between laziness and efficiency. Do you ever notice that? Well, there's a lot of qualities of a lazy person that an efficient person also has too. I like to lean towards the efficient side, but if you want to think of it, your motivation as laziness, that's fine too. We kind of have the same goals to do something with maximal impact but minimal effort, right? So I'm going to give you some hints that are going to reduce the amount of effort that you're going to need to spend on this to get something out of it. You ready? Couple hints. Now, if you don't want spoilers, then just ignore me. My first hint's going to be on number 65. And number 65 talks about the perimeter of this triangle. It actually gives you a number for the perimeter of the triangle. Could somebody please remind me, how do you find the perimeter of any shape? Totally. And in a triangle, that would be 3 of them, right? You would have side plus side equals the perimeter. That is how you find the perimeter. We know that fact. We are going to model our equation after that fact. A lot of people are going to look at this and want to say, write the equation that 7x minus 4 equals 10x plus 3, but that's not true. Those two sides are not the same. They're not the same length. What we know about all 3 of these sides is if we add the 3 sides up, it will equal to whatever number the perimeter is. And they told us that the perimeter is 52. So please use the information given about the sides in the picture to fill out the rest of your equation, and then you'll have an equation you can solve for x. Okay? Go ahead and finish writing that equation right now, and then I'm going to flip over on the back and give you some hints on the back side as well. Yeah, that's what you told me a second ago, that we just add up the sides, right? Totally, that's what the sides are. This side is 7x minus 4. Put that one there. Actually, it doesn't matter what order we put them in, right? Because we can add things in any order. So yeah, I'm just copying these 3 things into these blanks. You're going to see me use this strategy a lot in this class when we have to go write equations. I will write an equation with blanks in it, and then I'll go back and fill in the blanks. I'll kind of try and figure out what's the concept of what this equation should look like, and then separately I'll fill in all the numbers and x's and stuff. Divide and conquer. And we'll talk more about that later. All right, this is a big one. Last year I had someone spend 30 minutes on this problem, number 66. I would rather you spend 30 seconds on this problem, okay? So we are estimating the area of these shapes. So I just want you counting up squares, and if a square isn't completely full, see if there's another little piece that you can combine it with to make a full square, and give me an estimate for how many square units each of these shapes are. If you come in within 2 or 3 of my estimate, then we'll call it good, okay? I do not need you to go home and look up formulas for the area of an ellipse or semicircles or all that other stuff. Just estimate it. So estimates on this, it actually says approximate here, so I'll just circle that. And then I want to give you a hint on 67 and 68. Did you notice yet that the equations are exactly the same in 67 and 68? But what I'm asking you to do is different. In 67, you're going to solve for y, and you're going to put 0 in for x. In 68, you're going to solve for x and put 0 in for y. So I'm going to show you what your first step's going to look like for part A for each of these. Here, they're telling you that x is 0, so you're going to rewrite your equation. Except when you get to that x, you're going to leave it out. And what number are you going to put in for x? 0. And then you're going to solve that. You're going to do some steps of algebra, and you're going to come up with y equals some number, and that will be your answer. Very simple. And then in part D, it asks you to find the y-intercepts. It's going to be 0, comma, whatever that number you just got is going to be your y-intercept. Very simple. Okay? In the next problem, you're going to do the same thing, except this time you're putting 0 in for y. So my equation is y equals, now it's 0 equals. I don't know what x is, so I'm going to leave it as an x. And then I'm going to do some steps of algebra, and I'm going to solve and figure out what x equals. And that'll be my final answer. All right. And to find your x-intercepts, it's going to be something comma 0, and whatever that number is going to be that first number. And the last hint I'm going to give you here is on part B here. I am going to tell you that when you go to solve this equation, you are either going to need to factor or use the quadratic formula. And if you would like a quick reminder of how to do either of those 2 things, just ask me. We got plenty of time today. All right, guys, thanks for your attention. You are free to move about the cabin. Get busy on this and let me know how I can help you. Thank you, thank you. I do not think we need a seating chart. Not for tomorrow anyways.